Children, it is a continuation of the chapter Coordinate Geometry. Now let us continue the exercise first, that is exercise 1 of the chapter. The 7th question. Find the point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. Now one point is on the x-axis and the other 2 points are given. Now let us consider the point A is the x-axis, and you know that point on the x-axis is of the form x0, and the other 2 points are P and Q. Let us have the coordinates of the point P are 2, minus 5, and the coordinates of the point Q are minus 2, 9. Here these are the 3 points. One is the point on the x-axis, that is in the form x0, and the other 2 points are P of 2, minus 5 and Q of minus 2, 9. So let us take, we know that the point on the x-axis is of the form x0. So let us have, let A is a point with coordinate x0 and P is a point with coordinates 2, minus 5, and Q is a point with coordinates minus 2, 9. The points P and Q are at equidistant from the x, means the point on the x-axis are equidistant from 2, minus 5 and minus 2, 9. So you can have AP is equals to AQ. The distance of the point P equals distance of the point Q from A. So you can, it is given that, what is given? It is given that AP equals AQ. From A, P and Q are at equidistance. Distance of the point P from A equals the distance of the point Q from A. So AP equals AQ. Now here AP equals, here you take for AP, right? For AP, A is a point with x0 and P is a point with 2, minus 5. So you consider these are x1, y1, these are x2, y2. Now you take AP equals what? Whole root of x2 minus x1 whole square plus y2 minus y1 whole square, that equals whole root x2 is 2 minus x whole square plus minus 5 minus 0 whole square. Then you will get, that equals, write this as it is. Let us see afterwards. Now you consider this is AP. Next for PP, right? For AQ. For AQ, right? That is, the points are A with the coordinates x0 and Q with the coordinates minus 2, 9. So you write x1, y1, x2, y2. Then AQ equals, you write whole root x2 minus x1 whole square plus y2 minus y1 whole square, that equals what? Minus 2 minus x whole square plus y2 minus y1 is 9 minus 0 whole square. It is given that AP equals AQ. AP equals AQ. So you write, as AP equals AQ, AP is square root of 2 minus x whole square plus minus 5 minus 0 whole square equals square root of minus 2 minus x whole square plus 9 minus 0 whole square. Remove the root on both the sides. You will get 2 minus x whole square plus minus 5 whole square, and it is minus 2 of minus of 2 plus x whole square plus 9 square. Then we expand this by using the identity x minus y the whole square or a minus b the whole square. That is 2 square minus 2 into x plus x square. Square of minus 5 is 25. Minus 5 whole square is 25 equals, then it is 2 plus x whole square. Minus of 2 plus x the whole square is 2 plus x whole square plus 81. 9 square is 81. Then you write 4 product of 2x. 2 2s are 4, 4x plus x square plus 25 equals, again we expand it by using the identity a plus b the whole square or x plus y the whole square. You will get 2 square plus 2 into x plus x square plus 81. Then you will get 4 minus 4x plus x square plus 25 equals 4 plus 4x plus x square plus 81. Now you observe both LHS and RHS. Here 4 cancels and x square cancels. Now you minus 4x, bring this 4x to the LHS, you will get minus 4x. Then you take 81 minus 25. 81 minus 25, transfer 25 to the RHS. Then minus 4x is minus 8x equals 81 minus 25. 81 minus 25, you will get 56. So you write 56. Then x equals 56 by minus 8. So 8 ones are 8 sevens are minus 7 you will get. Minus 7. Therefore, the point on the x-axis, the point on the x-axis which is equidistant from 2 minus 5 and minus 2 9 is minus 7 0 is minus 7 0, because it must be in the form of x0, y value must be equals to 0. So you got the coordinates of the points on the x-axis which is equidistant from 2 minus 5 and minus 2 9 is minus 7 0. Now the next question, question number 8. Find the values of y. Find the values of y for which the distance between the points P of 2 minus 3 and Q of 10y is 10 units. So you take here what is given, the distance between the points P and Q, PQ is given. PQ equals 10 units. And P is a point with coordinates 2 minus 3 and Q is a point with coordinates 10y. We have to find the value of y. So you write the formula for distance, that is the distance formula. PQ equals whole root x2 minus x1 whole square plus x2 minus x1 whole square plus y2 minus y1 whole square. The distance is given, that is 10. Now you consider this is the point x1, y1, this is the point x2, y2. Then PQ equals, you write the value, square root of x2 is 10 minus 2, 10 minus 2 whole square plus y2 is y minus of minus 3 whole square equals 10. Now you remove the root, take the square on RHS, that is here square root of, you write first, 10 minus 2 is 8 square plus y minus minus 3 is y plus 3 whole square equals 10. Then you remove the root here, take the square on that side. So you got 8 square plus y plus 3 whole square equals 10 square. Here the square root is cancelled on the LHS, we have to take the square on the RHS. You got it. Then y plus 3 whole square equals 10 square minus 8 square. Then y plus 3 whole square equals, then you can write it as 10 square value 100 and 8 square value 64. Otherwise use the identity a plus b into a minus b, that is 10 plus 8 into 10 minus 8. Whatever it means you can use. 10 square is 100, 8 square is 64. Then y plus 3 whole square equals 100 minus 36 is, or 64 is 36. Y plus 3 whole square equals 36 you got. So y plus 3 equals, you take root here, 36. Here cancel the square, take the root on RHS. Y plus 3 square equals 36. So y plus 3 equals what? Root 36. You take y plus 3 equals plus or minus 6, because square root of 36, because 36 equals 6 square or minus 6 whole square. Therefore you take the y plus 3 equals plus or minus 6. Then you can take y plus 3 equals 6 or y plus 3 equals minus 6. Then y is equals to what? 6 minus 3, or y is equals to minus 6 minus 3. Then it is y is equals to 6 minus 3 is 3, or y is equals to sum of minus 6 and minus 3 is minus 9. So what are the values of y? Y equals 3 or y equals minus 9. 3 or minus 9 are the values of y. 3 or minus 9 are the values of y. Now the ninth question. If q of 0, 1 is equidistant from p of 5 minus 3 and r of x 6, find the values of x. Also find the distance qr and pr. Now you observe that here the points p and r are at equidistant from q. The distance between p and q equals distance between q and r. Then you take the point. P is a point with coordinates 5 minus 3 and Q is a point with coordinates 0, 1. R is a point with coordinates x 6. And what is given? Given that Q is at equidistant from P and R, that is PQ equals RQ. What is given? PQ equals RQ, and for PQ you take the point P and Q. P is a point with coordinates 5 and minus 3 and Q is a point with coordinates 0 and 1. So PQ equals what? PQ equals square root of x1 y1, this is x2 y2. You write x2 minus x1 whole square plus y2 minus y1 whole square. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. And pq equals, what is that? Square root of x2 is 0, 0 minus 5, 0 minus 0 minus 5 whole square plus y2 is 1 minus minus 3 whole square. That equals, what you got? 0 minus 5 whole square is minus 5 whole square plus 1 plus 3 whole square. That equals 5 square is 25 plus 4 square. 1 plus 3 is 4, 4 square is 16. That equals what? Root 25 plus 36, 16 is 41. What you got? 41. Root 41 you got. Next you take, that is RQ. For RQ, you write R is a point with coordinates x6 and Q is a point with coordinates 0, 1. Then to write the distance formula, you consider this is x1, y1, x2, y2. Then you write the distance formula RQ equals square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is RQ equals x2 is 0, 0 minus x whole square plus y2 is 1 minus 6 whole square. That equals minus x whole square plus 1 minus 6 is minus 5 whole square. That equals x square plus 25. X square plus 25. So it is given that PQ equals RQ. As PQ equals RQ, what is PQ? PQ is root 41. RQ is root x square plus 25. Now you remove the root on both the sides. You will get 41 equals x square plus 25. That is nothing but x square plus 25 equals 41. Then x square equals, so x square equals 41 minus 25. Then x square equals 41 minus 25 is 16. So you got x equals square root of 16. So you got x equals plus or minus 4. X equals 4 or x equals minus 4. Then the question is, find the distance QR and PR. If x equals 4, then you find PQ. PQ is already there, that is root 41. And then to find PR, P is a point with coordinates 5 minus 3. R is a point with coordinates x and 6. So you can take x equals 4 or x equals minus 4. So if x equals 4, then P of 5 minus 3 and R of x6 you have to get. Now you write PR equals, consider this are the point x1, y1. These are the point x2, y2. Then you write whole root x2 minus x1 whole square plus y2 minus y1 whole square. Then PR equals square root of x2 is, here let us take, that is the 4 let us take here, this is 4. So 4 minus 5 whole square plus y2 is 6, y1 is minus 3, 6 minus 3 whole square. Then it is, you can write 4 minus 5 is minus 1 whole square plus 6 minus of minus 3, 6 plus 3 whole square. Then it becomes 1 square plus 9 square, which equals 1 plus 81, that equals square root of 82. So we got PR equals square root of 82. And also you take minus 4. That is, if x equals minus 4, then the point becomes P of 5 minus 3 and R of minus 4, 6. So these are x1, y1, x2, y2. Then you write PR equals square root of x2 minus x1 whole square plus y2 minus y1 whole square, that equals x2 is minus 4 minus 5 whole square plus y2 is 6 minus minus 3 whole square. Then PR equals, we got minus 5 minus 5, minus 4 minus 5 sum is minus 9 whole square plus, again it is 6 plus 3, you will get 6 plus 3 whole square. Then PR equals 9 square is 81, 6 plus 3 is 9, again 9 square is 81. So you will get 162. Sum of these two is 162. Again it is 81 into 2, then 9 root 2 you got. That is 9 root 2. So if x equals 4, you will get square root of 82. If x equals minus 4, you will get 9 root 2. Therefore, you can take PR equals, first one is root 82 or 9 root 2. Root 82 or 9 root 2. 10th question. Find a relation between x and y such that the point xy is equidistant from the point 3, 6 and minus 3, 4. Now let us consider P is a point with coordinates xy and Q is a point with coordinates 3, 6 and R is a point with coordinates minus 3, 4. And it is given that xy, the point P with coordinates xy is at equidistant from the points Q and R. So it is given PQ equals PR. The point P is equidistant from the point Q and R. So PQ equals PR. It is given. Now for PQ take, for PQ, P is a point with xy and Q is a point with 3, 6. So consider this is x1, y1, x2, y2. Then you write formula for PQ. PQ equals whole root x2 minus x1 whole square plus y2 minus y1 whole square. Then PQ equals whole root x2 minus x1 is 3 minus x whole square plus y2 minus y1 is 6 minus y whole square. Then second, for PR, you take P is a point with xy and R is a point with minus 3, 4. R is a point with minus 3, 4. Then PR equals, again you take square root of x2 minus x1 whole square plus y2 minus y1 whole square. So again you consider this is x1, y1, these two are x2, y2. Then PR equals whole root x2 minus x1 is minus 3 minus x whole square plus 4 minus y whole square. As PQ equals PR, you take square root of 3 minus x whole square plus 6 minus y whole square equals square root of So this one you can write minus 3 minus x you can remove, minus outside, that becomes 3 plus x whole square plus 4 minus y, otherwise it becomes confused for you. So that you take, that is 3 plus x whole square plus 4 minus y whole square you can take. So you write that is 3 plus x whole square plus 4 minus y whole square. Then you remove the root on both the sides. So you got 3 minus x whole square plus 6 minus y whole square equals 3 plus x whole square plus 4 minus y whole square. Then here you bring 3 minus x whole square minus 3 plus x whole square here. Here you take 4 minus y whole square minus 6 minus y whole square. You can use the identity a square minus b square, a plus b into a minus b. So it becomes 3 minus x plus 3 plus x, one factor, and other one is 3 minus x minus 3 plus x, the second factor. Here also 4 minus y plus 6 minus y, one factor, and the other factor 4 minus y minus of 6 minus y. So this is a plus b into a minus b. Here also a plus b into a minus b. So while taking minus of b, you must take the bracket for 3 plus x and 6 minus y. Here we have taken, see, 2 terms are there, so you have to take the bracket. Here also 2 terms are there, so you take the bracket, otherwise bracket is not required. Then minus x plus x cancel, 3 plus 3, 6, and open the bracket, 3 minus x minus 3 minus x, and here it is minus 6 minus, it becomes 4 plus 6, 10, 10 minus 2y you will get, and here you open the bracket, 4 minus y minus 6 plus y. Then it is 6, 3 minus 3 cancels, minus 2x you will get. Here 10 minus 2y and minus y cancels, 4 minus 6 is minus 2. Then if you want you multiply, otherwise you can cancel, or you multiply. If you want to cancel, it becomes minus 2 1s, minus 2 minus 3s. Then you multiply, that becomes minus 3 into minus 2x, 6x equals 10 minus 2y. You got 6x equals 10 minus 2y. If you brought to the LHS, that becomes 6x plus 2y minus 10 equals 0 is the equation. Again you can remove 2 common, 2 into 3x plus y minus 5 equals 0. The equation becomes 3x plus y minus 5 equals 0. So you got the relation between x and y, that is 3x plus y minus 5 is equals to 0. Therefore, the relation between x and y is 3x plus y minus 5 equals 0. You got it? 3x plus y minus 5 equals 0.